Dude, this alkyne stuff is honestly not making any sense to me.
Yeah, man, I don't understand that stuff at all either.
Same, all this hydration of alkynes and tautomerism, bro, it does not make any sense.
The additions and like, it's just getting out of hand, you know?
And I know what you mean. Yeah, let's just take a break for a second.
Yeah, let's just...
Yeah, down for that? Alright, let's do it.
Just hang out for a sec, just chill.
And,
Alkynes, you know they reacting. Alkynes triple bottom through them hydrocarbons. Triple bonds the shortest and I'm not just bluffing. You know all this, okay, got my head so flustered, woo! Call me DJ Steric cause you know I'm clustered, woo! Asking questions in class with my left hand up like, woo! Gotta hit this bonus for all the questions that I missed. Addition by electrophilic reagents. Alkynes, you know they reacting. Alkynes all up in this discussion. Way too many questions, is OChem hard for you? You searching for answers, I do not know nothing, woo! Where you going, what are you a leaving group? Alkynes, you know they reacting, woo! Alkynes, this transition not an attribute. OChem, you know there's a final coming soon.
Wake up, guys.
Alright, now that you guys got that out of your system, we're gonna jump on these alkynes, man.
Alright, we're going to be talking about alkynes, which is a triple bonded hydrocarbon. As you can see, the triple bond is right here. A carbon-carbon triple bond can be located at any unbranched location, such as right here, which is called a terminal. Since a triple bond is sp hybridized, it is 180 degrees. The least amount of carbon in a ring that has a triple bond is 10 carbons. Alkynes and alkenes have a lot of similar characteristics such as regio and stereoselectivity. Alright, so we're going to be talking about catalytic hydrogenation. Catalytic hydrogenation is an addition reaction between a molecule and H2 hydrogen, which usually involves a catalyst. Because of the stability or lack thereof, for alkynes, when a PT or PD are used for the hydrogenation, catalyst is so effective that the alkene intermediate can't even be isolated. But by using Lindler's catalyst, the alkyne can be converted into a alkene without further reduction, and the hydroselectivity is usually a SYN. Alright, so we're going to talk about addition by electrophilic reagents. This reaction is different in that it is more exothermic than an alkene reaction of the same nature, but the rate of addition to the alkyne is slower. So even though this is a slow reaction, it still displays some of Markovnikov's rule of regioselectivity and anti-stereoselectivity. Since the product does not produce a substituted alkene, it can undergo more addition. Alright, so this is the example I was talking about before. Because this one does undergo a substituted alkene, it can undergo further addition in comparison to this one where it does not produce a substituted alkene, so it can no longer go any further addition. The reason alkynes are more sluggish than alkenes, even though it is more exothermic, is because there are more pi electrons associated with a triple bond, and the sp hybridized carbons exert a strong attraction on these pi electrons. This graph right here demonstrates the different activation energy of an alkyne. So the transition state is up here. And
Our next reaction is the hydration of alkynes. The addition of water to alkynes requires a strong acid, for example, sulfuric acid. And in this example, it is facilitated by the mercuric sulfate. The addition of water generally to alkynes, it gives a ketone product. In this example, you can see the tautomerization of the intermediate leads to the ketone product. Reactions of alkynes with oxidizing agents usually result in cleavage of the triple bond to give carboxylic acid and product. The general equation right here is used to show this. For example, as you see, the carbons are triple bonded to each other, which leads to, after the addition of the oxidizing reagent, which is symbolized by O usually, you see you get your carboxylic acid products here. And this carbon now has a double bond to an oxygen, which remember when something is oxidized, it gains a bond to a more electronegative atom and or it loses a hydrogen bond. In this case, our carbon gained bonds to the more electronegative oxygen after losing the bonds to the carbon.
Whoa, man, that was crazy.
Whoa, Asher, where'd you come from?
You don't even want to know, man. I've been through all kinds of trouble.
It's the